Hey, what's up, guys? Welcome back to the channel. My name is Sakal, and let's learn networking together. As a network engineer, network security is one of the most important aspects in your production network. So, it's important to protect your internal network from the uh, public network. So, here we are going to configure Huawei firewalls, that is the Huawei Firewall USG6000, and we are going to implement redundancy. So we are going to configure two firewall 1, which is going to act as the active firewall, then firewall 2, which is going to act as the backup. Again, we are going to configure the NAT policy, that is going to translate the public IP address into private IP address. So also we're going to configure the security policy to secure our network. So what do we mean when I say NAT? NAT is just a short form for the network address translation, which translates the public network into private network and private network into a public address. So we have got the private addresses. So private addresses, I hope you guys have learned the addressing, IP addressing. So private addresses, we have got three set of private addresses. So private addresses. Let's look at the range for private addresses. So number one, the first range from 192.168.0.0 all the way to 192.168.255.255. That's the range for to use in your internal network. That is the network within your intranet. Then number two, the range for the second private network will be 172.16.0.0 all the way to 172.16.31, not 16.31.31.255.255.255. So meaning that and then the third one is the third private network will be 10.0.0.0 all the way to 10.255.255.255. So these are the range that can be used in your in your internal network, that is the intranet. So when you configure an intranet, so these are the range that you should consider. But when the IP address is outside this range, like for instance here we see 200.1.1.0/.4, that is a public address because it's outside the range for these private addresses. Any address outside this range, that is a public address. So that's where we need the public address. This is the addresses that is used to access the internet. That is the network beyond your internet. So that's why we need a network address translation. The network address translation is also another way to implement security. You can secure your network through a NAT because while accessing the public network, you are going the IP address of your internal network is going to be translated to a public network. So meaning that external users, the user on the on the internet, won't be able to know the IP addresses you are using in your internal network. So those are one of the things we're going to implement. We're going to configure security and we're going to configure NAT. So also we are going to implement reliability. So in case firewall 1 fails, firewall 2 should be able to take over the role. Again here, we are using a USG firewall. So USG firewalls, this one USG6000V, is a highly secured Huawei firewall that is you have to log in. When you log in, so these are the logins. So when you log in, the username is admin and the password is admin 2123. You'll be required to change the name. You can change the name you like. For your case, sometimes you find that a USB firewall fails to start. So when your USB firewall fails to start, make sure you you power off your Windows Defender firewall before you start your USG firewall. Also ensure, because sometimes find that some laptops you must be connected to the network. So before you start that USG firewall, ensure that you connect to a network for it to start. So let's look how the requirement for this practical. So configuring hot standby on Huawei Firewall USG, configuring hot standby on Huawei Firewall USG6000. So the overview: when doing the network architecture design with Huawei Firewall USG6000, we have to be aware that the key places in the production network environment usually require two network devices for high availability. This article will configure active and standby on Huawei Firewall model USG6000. So when one firewall unit fails, another firewall unit will take over devices to ensure continuity of the services. Then a prerequisite here, what we are just required is that you've downloaded the ENSP. So if you've not downloaded the ENSP, you can follow the link here. I'll leave it in the description, in the comment section. So you can download the ENSP and also download the image file for the USG Firewall 6000. So you are also required to know how to configure the NAT. So if you want to know how to configure the NAT, you can follow also that link. Then the lab scenario setup. We will set up a lab to configure active and standby on Huawei Firewall USG6000 as shown in the diagram below. There is one router in the LAN with the host name as PC1, and this host is acting as an inside LAN client computer, i.e. the intranet. A router with the host name AR is a gateway for the client computer. Firewall 1 will be active firewall. Firewall 2 will be the standby firewall. One router acts as the internet, and another router in the hostname PC2 acts as the computer in the public network. Interface gig 1/0/3 on firewall 1 is connected to firewall 3, firewall 2 for the heartbeat link. So the heartbeat link is that which is going to help for both the two firewall be able to synchronize. So this is how our topology look like. The topology we've set on our ENSP. So this is what we are going to configure. So with that, let's just begin our practical. So first of all, we are going to log in into our firewalls and change the firewall name. So we said the username was admin. Then you enter the password was admin at 123. Then it require you to ask you if you want to change. Say yes. After that, you enter again that password, the old password. Then you enter new password. So new password, we're going to use caps Huawei at 123. Then you confirm the new password, Huawei at 123. So after that, just change the device name before you go. So device name, this is firewall 1. Firewall 1. Also come to this other firewall, and also you change the authentication. So this was admin 123. Then you enter the new, say yes, and enter the old password, admin at 123. After that, the next thing, you configure the new. Huawei at 123. Confirm the password. Huawei at 123. After that, we change the device name. So this is going to be Firewall 2. So that's it. And after that, the thing we are going to do is now configure the IP addresses on the interfaces. We want to configure the IP addresses on the interfaces. So let's just begin with that firewall, there. So when you see this firewall, the interfaces for this for gig 2 here, the IP address is this one. Then for gig 3, the IP address is this one. Then for gig 1, the IP address is 10.0.0.1. So you can see here some are /30, some are /29. As we proceed, we are going to see how you can configure the wildcard mask for those /30. So /30 here, meaning that we have got how many hosts? We have got only 2 hosts. So enter the interface. So first of all, let's undo terminal. So on that firewall, we are going to configure IP address at the interface gig 101 gig 1/0/1 IP address. We are going to give it IP address of 10. That's the interface that connects to the downward router 10.0.0.1/30. Then gig 102 IP address that's connect to the upper switch. Gig will be 200.1.1.1. So this one here, 200.1.1, is a /29. Then we enter gig 3, the heartbeat link. That's gig 3 IP address will be 10.10.10.1. This is a /30. The /30. So after that, you also come to this other firewall, also configure the layer 3 ATM interface gig 101 gig 1/0/1 IP address. We are going to give it 10.1.0.0.1. Sorry, 10.1.0.1 is a /30 also. And gig 102 IP address will be 200.1.1.2 /29. Then configure the heartbeat link, that is gig 3. Gig 103 will be IP address of 10.10.10.2 as a /30. After that, the next thing we do, we've configured for that firewall. So when you look at switch 1 here, we won't configure anything on that switch. This is just acting as the bridge, as just from the bridge logic. The bridge, you just pass through the bridge. It helps you to pass through the other side of the road. So that's the role of that switch. It will just allow packets to pass through to router on the internet here. So we've configured the interfaces for the firewall, and let's configure the interface for this router on the internet. So this router on the external network. So on that router, we give it the name. So just let's configure it as internet. So internet. Then that internet router, we are just the thing we are going to configure on this router is just only the interfaces and the IP addresses. So interface gig0, interface gig0/0/0, give it IP address of 200.1.1.4. This is /29. Then you enter gig1 that connect to a PC2 there, the router that acts as the PC. So that's gig1. Give it IP address of 100.1.1.1/30. After that, you come on this PC. This PC which will act, this router which will act as the PC, also configure the interface. Give it an IP address. So this is PC1, PC2 I mean. PC2, enter interface gig0/0/0. Give it IP address of 100.1.1.2/30. Come and do the same to the this router here. This is going to act as the gateway for PC1. That router also, I will enter the interface and give it the IP addresses. Change the device name. This is router 1, say router 2, and say it's the gateway, and it's the gateway router. Then I enter the interfaces, interface gig, start from gig0/0/0. IP address, we give it IP address of 10.0.0.2. This is /30. Then you enter gig1 that connect to firewall 2. IP address, give it 10.1.0.2/30. Then the interface that connect to PC1, so that is gig2, give it an IP address of 20.0.0.1 /24. So meaning that we've set IP addresses on those interfaces. The next thing we are going to do is enable communication. That is meaning we are going to configure the OSPF, and also we are going to configure the static routes. So here we are going to use the default routes, that is 0.0.0 with a mask of 0. So when you enter this network, quit. So we are going to use OSPF. So OSPF, you can see the router ID. The router IDs for this router here is 172.16.0.3, and for firewall the router ID is 172.16.0.1. and firewall 2 is 172.16.0.2. So we are going to configure OSPF on the firewall 1, firewall 2, and as this router which acts as the gateway here. And both we are going to use area 0, that is the backbone area. So OSPF process ID 10, then router ID will be 172.16. Router ID is what identify router in an OSPF network. So .0.3. After that, the next thing we are going to is to configure area, this area 0. Then we advertise the networks on that router. So the network of 1 of 20 20.0.0.0 wildcard mask of 0.0.0.255. I'm going to explain that, and a network of 10.0.0.0 wildcard mask of 0.0.0.3. I'm going to explain the difference why this one is a .3 and the other one is .255. Then another network of 10.1.0.0 a wildcard mask of 0.0.0.3. Enter. So let me explain why another one is .3 and another one is .1. So first of all, let me show you the bits, how the bits work. This should be 8. 1, 2, 3, 4, 5, 6, 7, 8. So this this will be 2 power 7, 2 2 power 7, 2 power 7. The first bit is 2 power 7. Then the second one, the first bit here is 2 power 7. 2 power 7. This one is 2 power 6. 2 power 6. This is 2 power 5. This is 2 power 4. Then this one is 2 power 3. 2 power 2. 2 power 1. 2 power 1. Then the last one will be 2 power 0. So 2 power 7 should be 128. 2 power 6. 2 power 6 is 64. 2 power 5 is 32. And 2 power 4 is 16. 2 power 3 is 8. 2 power 2 is 4. 2 power 1 is 2. And 2 power 0 is 1. When you add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, the total should sum up to 255. That is for one subnet. Now how we get this one /30 here. /30 meaning that the first octet is full. We have got IP addresses divided into 4 octets. So the first octet carry 8 bits, the second octet carry 8 bits, and the third octet carry 8 bits, and the fourth octet also 8 bits. When we take /30, so meaning that we have got 31 bits. So meaning that 8 times 3 should give us 24. 24 plus 6. 24 plus 6 will give us /30. So meaning that the last two bits are the one that will be used. The last 2 bit won't be used. This last 2 bit are the one which will be used for the host won't be included. They will be 00. So meaning that the fourth octet for that slash 30 will have how many binary bits for 1? We'll have got 6. So 6 of them. So meaning that the last 2 bits which will be for the host will give us let's add their value will be 2 plus 1. So 2 plus 1 is 3. So that's why, like, if this is a slash 30, if this is a slash 30, slash 30, slash 30, the wildcard mask, not the mask, the subnet mask should be 255, 255 dot 255 dot 255 dot. Now subtract 3 from 255, we'll get 252. So that is its mask. That it is subnet mask. That is the subnet mask. That is a subnet mask. Now, for configuring OSPF, we use what is called wildcard mask. So wildcard mask, the wildcard mask for that subnet mask will be 0. When you subtract 255 from 255, will be okay. Let me show you. Let me explain it here first of all. So slash 32 will be 255 dot 255 dot 255 dot 255. That's for the full. Now we want to get the wildcard mask. So the wildcard mask, what we do, we just subtract here. You put a subtraction sign here. Then when you put 255 minus 255 will be 0. 255 minus 255 will be 0. Dot 255 minus 255 again will be 0. 255 minus 255 will be 0. Then 255 minus 252 will be 3. So that will be the wildcard mask. Wildcard mask. So that's how you come up with the wildcard mask, guys. That's how you come up with the wildcard mask from the subnet mask. So that's what we've configured on this here. This is a slash 30. We gave it dot 3. But what if slash 24? Slash 24 meaning that the first three octets, that is 8 plus 8 plus 8, will give us a total bits of 24 bits. So meaning that the last 8 bit won't be full. So meaning that for here, what we are going to do will be 255. Let me show that also, so that you guys you can understand wildcard mask properly. So slash 32, that is for the default. So 255.255.255.255. Then for slash 24 will be 255.255.255. Then the last 0 will be for the host. So that one, when you subtract what we get, 255 minus 255 will be 0 dot 0. 255 minus 25 will be 0 dot 0 dot 255 minus 0 will be 255. So that's how we came up with the subnet mask, the wildcard mask for slash 24. Now we've configured the OSPF on that router. You quit, and let's save that. Also come to firewall here. We said firewall is highly secured. After some minutes, you will be logged out and you will be required to log in again. So the username was admin, password was Huawei 123. After that, you're going to configure the OSPF. So OSPF here, we said OSPF process of 10. Router ID here, router ID on this firewall will be 172.168.2.0.1. Then area we are going to configure area 0. The network that we are going to advertise, the network that connect to the downward router, so the network of 10.0.0. Before quit before quit again. So before we configure the network, we are going to advertise the default route. So our default route advertise type 1. The default route advertise type 1 advertises the default route to a common OSPF area. So this default route advertise step 1 is going to advertise the default route into the OSPF area. That's the area that we're going to create, that is area 0. So area 0, the network will be 10.1, 10.0.0.0, wildcard mask of 0.0.0.3. For that you quit. You can see it's able to exchange the LSS. It's establishing the neighbor relationship, and soon it will be in a full state. Then after that you quit and you advertise the default route with the next stop being 200.1.1.4. So IP route static. Here we advertise the default route, so any route 0.0.0.0.0.0. Welcome mask of 0. The next stop will be 200.1.1.4. So that route will be able to be advertised into OSPF area 0 because we configured the default route advertise. Come to this other firewall, so you log in. On that firewall, you also configure the OSPF. So OSPF process ID was 10. Then the router ID, the ID that is identify that router, that firewall in the OSPF area will be 172.16.0.2. Then default route, we are going to advertise the default route into OSPF common area 0. So default route advertise type 1. We are either type 1 or type 2. So type 1. After that, area, you enter the area. This is area 0. Area 0, you advertise the network, that network that is connected to gig 101. So network of 10.1.0.0, wildcard mask of 0.0.0.3. Should be able to see LSS being advertised and establishing neighbor relationship. After that, you quit. It's changing the LSS. After you quit, you configure the static route with the gateway.4. So IP route static 0.0.0.0. That's the wildcard, so 0. Then our next stop will be 200.1.1.4. That. After that, the next thing we're going to do, you also come on PC2 here. On PC2 here, we are also going to configure the default route with the next hop being 10.1.1.1. So IP route static 100.1.1.1. No, the default route, we are configuring default route 0.0.0.0. Wildcard mask of 0, that's a mask of 0. Then the next hop will be 100.1.1.1. You come to this PC here, the downward PC UTM. You didn't configure its IP address, so this one is the name you're going to give it is PC1. And the interface gig with IP address interface gig 0/0/2. IP address, we give it IP address of 20.0.0.10/24. You quit, and after you quit, you configure the static route. So IP route static. So you configure the default route 0.0.0.0, mask of 32 and mask of 0.0.0. The next hop will be 20.0.0.1. That is the gateway. Okay, after that, the next thing we do is we enable the OSPF on the interfaces. So we enable point-to-point OSPF, point-to-point OSPF. So you enter the interface. So interface gig 0/0/0. So OSPF network type. The network type here we're going to use point-to-point. Point-to-point. Also enter gig 1, the one that's on the OSPF, the interface that are on the OSPF. So OSPF network type here is going to be point-to-point. And also gig 3, gig 2, I mean gig 2, not gig 3, gig 2 will be also tell it us to use OSPF point-to-point. Also go on the firewall, and the firewall also you do the same interface, the interface that connects to the OSPF. So that is gig 101, gig 1/0/1. Then OSPF network type, this is point-to-point. So point-to-point. Also go on this firewall 2 here. So interface gig 101 OSPF network type point-to-point. Okay. Okay, the neighbor state is full. It has obtained the LSS, so the neighbor state is full. After you configure the OSPF to ensure that the routes are reachable, the next thing we are going to do is now to configure. We are going to configure now the hot standby, that's the active and the standby firewall, to ensure service synchronization. So in case one of the firewall goes down, the other one should be able to take over. Okay. So the next thing is to configure that HRP on that firewall. HRP is just Huawei redundancy protocol. So we're going to paste that HRP that is going to enable the firewalls to synchronize. But before we okay, let's before we configure that, we should configure, we add the firewall interface to the zone. So firewall zone, so firewall zone trust. Then the interface that we are going to add to the trust is the interface that connect to the intranet network. That's our private network. So that's the zone, the trust zone. Our production network is the network that need to be secured. So the trust network, we add the interface, add interface gig 101, gig 1/0/1. Then enter untrust zone, untrust. They add the interface, that interface that go connect to the upper on the internet, that is gig 2. Then you add the DMZ. The DMZ is the link that the interface that set up the HRP. So you quit. So firewall zone DMZ. The DMZ is the heartbeat link. So add interface gig 103, gig 1/0/3. You do the same to the other firewall. You add the interfaces to the zones. So firewall zone trust, add interface gig 101 1/0/1. We quit and add firewall zone and trust zone. You add the interface 102 interface gig 1/0/2. You quit and also add the firewall zone for the DMZ firewall zone. Add zone DMZ, the demilitarized zone. So at the demilitarized zone, we add the heartbeat interface. So add interface gig 103, gig 1/0/3. After that, you quit. After adding that, now we are going to create the HRP. So HRP, quit and HRP enable HRP. NAT IP detect function is disabled. So after enabling the HRP, so as you can see here, the HRP has been enabled. So HRP enable on that firewall. After enabling the HRP, the next thing we are going to configure is that HRP interface gig 1/0/3. Then the remote address for that will be the remote address will be 10.10.10.2. Then we are going to track we're going to tell it to track the interface that connect to the private network, the downward network, the network that we need to secure. So HRP track interface gigabit 0 gig 101. So gig 101 is the interface that we are going to track. I'm going to tell to track that downward interface of gig 101. After that, you come to this other firewall here. So you enable HRP enable. So you can see there. Then you tell it HRP standby device. So HRP standby. HRP standby device enable. So as you can see here, HRP has been enabled as a standby. After that, the next thing we are going to do, quit. After enabling the HRP, now we configure HRP, configure the heartbeat. So HRP interface gigabit 0, gigabit 1/0/3, that is 103. The remote IP, we tell the remote IP of 10.10.10.1. Then we tell it to track the down interface. So HRP track interface gig 101, gig 1/0/1. After that, meaning that our HRP, the heartbeat link is up now. Our HRP link is up. So as you can see, when you come here, you can be able to see that here we have been told that it is the master. So HRP here is the master. So meaning that this firewall 1 here is going to act as the active firewall. It has been given the master. Then when you come to firewall 2 here, it's the standby. So HRP standby. So HRP _S, meaning that it is the standby firewall, while this firewall here is going to act as the uh, main firewall. That's the active firewall. So that's how we configure the HRP. So after you configure the HRP, the next thing we are going to configure is now to configure the security policy. And lastly, we are going to configure the NAT policy. So policy, so security policy. So security policy here, the policy, the rule name, we are going to give it name, we are going to give it, let's say rule OSPF, rule underscore, sorry, rule underscore OSPF. After that, the next thing we are going to tell it, the network, the source will be a source zone will be local zone, inside the zone on the network. So after that, tell it the action will be action here is to permit. Then after that, the next you create the next policy, security policy. The next security policy will be rule. Rule will be rule name, trust underscore and trust. After that, the source zone will be trust. Destination zone will be the untrust. After configuring the destination zone, you tell it action to permit. Then you quit. Then you create another rule. So rule name. Rule name this time here we are going to give it SCL trust to local underscore local. Then the source zone we are going to be source zone. Source zone will be trust, and the destination zone will be local. That is the zone on that firewall itself. Then action, we tell action to permit. Action, we tell it to permit. Then you quit, and you quit to the user view. After that, we are going to configure the NAT policy. So the NAT policy here, the NAT policy, we're going to configure the NAT rule. So rule name here will be, let's say, NAT1. After that, source zone will be trust. Then destination zone will be untrust. So this one is going to help it now to translate the public private to public. Now action where will be not no not. So that action here, let's use source not. Source not easy IP. So here we are using easy IP. So action here is source not easy IP, not no parts. So after that, we are through. So meaning that because firewall one here is the master, we won't configure firewall 2 because they will be able to synchronize. Whatever you configure on firewall 1, I should mirror on firewall 2 here. So firewall 2 should have the same Okay, so that's how you configure. Now let's see if we are able to talk to PC any. So let's try to ping something here. Let's try and ping the gateway. Ping 20.1.1.0.0.1. It's able to ping. Now let's ping 200.1.1.1. It can't ping. There's a way firewall should enable it to allow ping permit. So guys, here what we do on this interface, on the interfaces, is what we do is now, because while we are on PC1 here, you can't ping PC2, or you can't ping either the gateway for that router, that is the internet router there. Why? Because the firewall are highly secured. They are blocking the packets. When you try to ping, they are blocking those ping packets. So until you enable the ping service on those interfaces, so this is interface gig 1, gig 2, and gig 3, you are going to enable a ping permit to allow packets for the SCMP packets to pass through. So you ping permit enable. After you enable ping permit, you also enable it to permit to allow ping. Then we also do on gig 1. So ping permit enable, and also you tell it to permit enable the ping service. So also gig 3 you tell it to enable ping service, enable service manage enable. Then you tell it service manage ping permits. Then now we are going to try to see if we can now ping that now. So ping 200.1.1.1. Okay, it's able to ping now. It's able to ping. It's able to reach that at internet gateway. Now let's ping .4. It's also able to reach .4, but can it now reach PC? PC on that the other PC2. That's PC2. That is ping 100.1.1.1. The gateway for that PC. Now it can ping the gateway for that PC2, but now can it ping the PC2 itself? That is .2. So that is able to run successfully. So meaning that our network here is able to talk to PC2 here on the network. So let's see if it is a reverse way. So ping PC1 here. So ping 20.0.0.1. It can't be able to ping because the thing is, this is an external user. This is a person on the app on the public network. It won't be able. The person won't be able to access our internal network. But this person on the internal network, the firewall is allowing this person to access the public network. So that's why we are able to ping from the internal network, but not from the public domain. So that's how you configure the firewall. So we said this one is going to act as the active firewall, then this one here is going to act as the standby. So we want to simulate in a scenario where the firewall 1 becomes faulty. So we are going to shut down this our firewall. We stop it to simulate the fault status. So after that firewall goes down, we want to see if it's still able to talk to the PC is still able to ping PC2. So meaning that, as you can see here, the interface for this link has gone down. So meaning it is firewall 2 that is going to act as our next. So enter firewall. So you see firewall 2 has turned to master state. Now, because the firewall 1 went down, so the firewall 2 here has turned to the master state. That is HRP master. Initially, it was HRP standby S, but it has detected it is very fast. It takes few seconds to come into an upstate. So it detected that the main firewall has gone down. So it has come to the upstate. So now it will be the master will be forwarding the traffic for to ensure that the production network is working properly. So you can see even after that has gone down, we are still able to reach PC2 on that external network. So that's how you configure hot standby, meaning that you ensure reliability on your network. When one of the firewall goes down, the other one should be able to take over the role of that firewall. So let's bring our firewall back. So if the firewall come back, let's see what happens if it's come back. Will it be the master or it will be the standby firewall? So I hope you guys you've enjoyed this video. That's how you configure firewall in your network. So means that once this firewall is started, when it gets back, it will still act as the master, and firewall 2 here will act as the backup. So thank you, and if you've not subscribed to our channel, remember to subscribe so that you can support our videos in case we throw a new video. You might like, so you'll be updated. So goodbye guys.